Now, if we look at number 7, example, it says there's a 220 volt DC shunt motor with your resistance of the armature is 0.5, takes a load current of 40 amp, and the second speed is 1.5 times the first speed, and the torque remains the same. So with the torque remaining the same, we have that IA2 is flux 1 over flux 2 times IA1. And then E1 normally is V minus IARA is 220 minus 40 times 0.5 gives us 200 volts. E2 is now going to be 220 minus 0.5 times flux 1 over flux 2 times 40. Then that means it's 220 minus 20 over flux 1 over flux 2. And then we say, all right, let's KT be equal to flux 1 over flux 2, and that is equal to X. Now they said that the speed is 1.5 times, so N2 over N1 is 3 over 2. And E1 over E2 is flux 1 N1 over flux 2 N2. And if we substitute those, we get 3 over 2 is 220 minus 20x over 200 times x. That gives us a quadratic equation. That is x squared minus 11x plus 15. And then we solve for x, and we got 1.6. The other value is too big, so we just ignore that one. So we know that flux 2 over flux 1 is 1 over 1.6. And to determine the change, it's flux 1 minus flux 2 over flux 1. So it's 1.6 minus 1 over 1.6 give us a 37.5 percentage change in the flux. So that the speed becomes 1.6 times 1.5 times. Any question there? Okay. Then if we go to example 7, we have a 10 kilowatt, 220 volt DC shunt motor with a speed of 2,500 revs per minute and the load current of 41 amps. We have the armature resistance of 0.2 ohms, the interpole 0.1, and the compensating winding is 0.05, and the field resistance is 110 ohm. Now, if we put a 1 ohm in the armature circuit, and the second torque is half of the previous torque, what is the speed going to be and the current? So flux 2 will be 0.75 of flux 1. And that's also given. So IF first is 220 divided by 110 is 2 amps. So the armature circuit, armature current is 39 amps. Now if we substitute that back into the equation for induced EMF, it is 220 minus 39 times 1.15. That gives us 175.15 volts. Then, because I said T1 over T2 is 1 over 5, and flux 1 over flux 2, we can say it's 1 over 39 times 0.75 times IA2. And from that, we can calculate the armature current is 26 amps. And therefore, E2 will be 220 minus 26 times 1.15, gives us 190 volts. And then E1 over E2 is N1, flux 1 over N2, flux 2. It's 175, which is that one, divided by 190 is equal to 2,500 times flux 1. And there they said that flux 2 is 0.75 of flux 1. So we stick it in there, and then we calculate that into is 3,617.85 revs per minute. I think there was a mistake in the book there. Just check it again. And then example 8. We have a 15 kilowatt 220 volt DC shunt motor running at 850 revs per minute with a load current of 72.2 amps. Armature current is 0.25 ohms. The field resistance is 100 ohms. N2 is 1650 revs per minute and IA2 is 40 amps. So we must see what we can do to the change in the field so that it will run 175. So field current is 2.2, so that gives us an armature current of 70 amps. And then E1 is 220 minus 70 times 0.25, which gives us 202.5 volts. E2 for 40 times 0.25, that's 210. And then E1 over N, E2 is N1 flux 1 over flux 2, 220, 202, sorry, to divide by 210. N1 was 850, and flux 1 and 165 to flux 2. So we stick into the formula and get that flux 2 is 0.534 flux 1. So therefore, we can say it is 1 minus 0.534 divided by 1. That gives us a 46% change in the field, so that we can determine then what is the resistance so that it will run at 1650. Okay, question 9 is basically same as exercise 9. Number 9 is the same as 8. So 10, again, we have 220 revs, 220 volts, 20 amp, armature current, armature resistance 0.5, N2 is 0.5, N1. So if we have R1 in series with the armature and the torque is the same, and also that the torque is directly proportional to the square of the speed. So therefore we can say T1 is equal to T2, and that means IA2 is IA1. So E1 is 220 minus 20 times 0.5, which gives us 210. Now E1 over E2 is N1 over N2. If we substitute it in there, we get that E2 is 105 volts. So E2 is V minus IR, so 105 is 220 minus 20 times R total. That gives us a total value of 5.75 ohms. And if we subtract the armature resistance of 0.5 ohm from it, then we get 5.25 ohm in series with the armature. Now the second condition, where the torque is directly proportional to the square of the speed, then T1 over T2 is N1 squared over N2 squared, and therefore IA1 over IA2 is 1 squared over 0.5 squared, and that gives us a armature current of 5 amps. And then it's 220 minus 5 times R total, and that gives us 23 ohms. And if we subtract the 0.5 ohm there, we get 22.5 ohms. So you see, it's all of them are playing around with those basic rules, formulas that I gave you in the beginning. And then example 11, we have a 250 volt, 1000 revs per minute DC shunt motor, armature resistance of 0.2 ohms, field resistance 250, and a line current of 8 amps. And what will be N2 be if the current then becomes 50 amps? So again, I shunt is V over F, that gives us 1 amp. So therefore the armature current is 7 amps. So it's 250 minus 7.2 gives us 248.6. And then in the second case, where the armature current is 50, the load current is 50, we get an armature current of 49, and that gives us 240.2. Now, they didn't say anything about the flux, so that means that remained constant. So therefore, E1 over E2 is N1 over N2. And if we substitute our values in there, we get that N2 is 966.2 revs per minute. Okay. Right. And then example 12. It says there 240 volt armature current resistance 0.25. Speed is 1000 revs per minute, and the armature current is 40 amp. And N2 is 800 revs per minute. If IA2 is equal to IA1, what was the external resistance in the armature circuit to get that the speed is 800 revs per minute? So then E1 is 240 minus 40 times 0.25. That gives us 230 volts. E1 over N, E2 is N1 over N2, and that becomes 184 volts. So our total is 240 minus 184 divided by 40, 1.4 ohms. So the external resistance is 1.15. Then the B part says when the current is 20 amps with the 1.4 ohm in circuit, then you get 212 revs per minute. So E1 over E3, N1 over N3, and 230, which is the first one, divided by the second voltage, which is our third voltage is 212, is 1000 over N3. So with this condition, then the machine will be running at 921.74 revs per minute. Now, example 13, we have a 7.48 kilowatt 220 volt 990 rev per minute with an efficiency of 88% DC shunt motor with an armature resistance of 0.08, field current 2 amp, and the second speed is 450 rev per minute. What is the series resistance in the armature? The output, the armature current, efficiency, if the torque remains the same. Now remember, the input is the output divided by the efficiency. So that gives us 8.5 kilowatt. And the losses is 12% because it's 88. So 100 minus 88 gives me 12 times 8,500 gives me 1.02 kilowatt. The input current then will be 38.636. And therefore, armature current is 36.633 because we subtract the 2 amps there from. Then the field loss is 220 times 2, which gives me 440 volts. The copper loss in the armature, IA squared RA, 107.4 watts. No load loss is 1020, which is that one, minus 107.4, that gives us 473. So E1 is 220 minus 36.636 times 0.8, which gives us 217.3 watts. E1 over E2 is N1 over N2, and therefore we find that E2 is again 108.5 volts. And the torque remains the same, so therefore IA2 will be 36 amps, and the total resistance is then 220 minus 108.5 divided by 36, that gives us 3.044 ohms. We subtract the armature current, we get resistance, we get 2.964 ohms. Any question there? Then the last one that I've prepared so far, okay, that goes on. Armature current total is 36.636 squared. It gives us a total of 4084 watts. Total is 440 plus 473 plus 4089. That gives us 4997.9 watts. Output is the input minus the output losses is 3.5. And the efficiency is then 3.502.1 divided by 8,500 gives us 41.2% efficient. And then the last one for me tonight is we have a 220 volt DC shunt machine with armature resistance is 0.4, field resistance 200 ohm, T2 is equal to T1, IA1 is 20 amps, running at 600 revs per minute, and the second speed is 900 revs per minute. So what is in the series field to produce that speed? So E1 is 220 minus 20 times 0.4, and gives us 212 volts. Field current is 220 divided by 200 is 1.1 amps. Now, here's where we get stuck. The torque is constant times the flux times the armature current. And E is another constant times the field current times the speed. So 202 is K2 times 1.1 times 600. So we have K2 is 0.3212. Torque is K1F field 1 IA1. So I field 2 I2 is 1.1 times 20. That gives us E2. Now if we substitute it in E, is 220 minus 0.4 times IA2, which is equal to 900. And a little bit of manipulation, 220 minus 0.4 times 220 over IF2 is 0.3212 times 900 times IF2. And then we have 220 minus 0.4 times 220 over I field 2 is 289 IF2. Now they said that it's linear and it's not saturated the field. So at 1.1 field current, it was 600 revs per minute. And then what will it be at 900 revs? So 600 over 900 gives us I field 2 over 1.1. And therefore I field 2 is 0.733 amps. Right, any questions so far? Although these problems are in the book, I'll photocopy them and I'll put them on your WhatsApp group. And the moment that this